An item which was postponed from last week's programme was Dr. Mino Green talking about electrochromic display, which may one day replace liquid crystal display. Talking to him now is Dave Garney.
Most people who have digital watches may be aware that the display is called a liquid crystal display. Well, a new form of solid-state display, known as the electrochromic display, has been developed by Dr. Mino Green of Electrical Engineering, who is with me today in the studio. Could you tell us, Dr. Green, a little bit about this electrochromic display?
Well, I think the most important thing about it is that it's an all-solid-state display, that it is an electrochemical device, that it makes use of two basic physical phenomena. One, the ability to have high conductivity in a solid electrolyte. In this particular case, we're talking about conductivity by virtue of the motion of sodium ions. And the other solid-state phenomenon is that when you insert a sodium atom into a host solid like tungsten trioxide, it goes from colourless to blue.
How similar is it to the liquid crystal display I mentioned that most people have got in their watches, their digital watches?
It's utterly different. The liquid crystal display is a low current, high field display with no inherent memory. The electrochromic display is a low voltage, high current device, electrochemical device with memory.
Do you envisage this, your new device, as replacing LCD in the future?
I believe that is the major area of competition. I believe that if we succeed the way we hope we will, that a number of devices which currently work with liquid crystals will be displaced by this device.
Now, I believe we have a demonstration of one of these crystals in action. Perhaps you'd like to talk us through.
Yes, we do.
So here is a display that's actually working, is it?
Well, no, this display is not working. This is a set of 10 squares, each 2 millimeters on a side, which have been colored to a different density.
Now this one's flashing.
Here we see one flashing with about 3 millicoulombs per square centimeter of sodium inserted. And now here we see a device being turned through an angle. The object of this demonstration is to show you that there is no restriction on viewing angle on these devices.
With an LCD, that would have disappeared by now,
you would not be able to see anything at this angle with an LCD.
So the advantage of this type of display is over an LCD is that it can have a very low angle of incidence and still be seen.
That's absolutely so. I think it's going to go even lower in a moment, if I remember correctly.
So you can still see it flashing?
Yeah.
Well, Dr. Green, that was a very impressive display, but could you tell us what sort of application it might have?
Well, I think that the sort of application that I envisage in the first instance would be, for example, motor car panel displays, instruments, clocks, and I think we would have to say that it's not terribly likely that they'll go into wristwatches.
Is that because of the power requirements?
Yes, I think so. And then there'll be a gap until we can multiplex these and get them into matrices so that you can actually have VDU displays.
Do you think of the TV display?
Well, not a colour TV and not at TV picture rates, but the sort of thing you'd have on the end of a computer terminal.
Mm-hmm. And are any firms interested in this idea?
Yes, we have one British firm particularly interested who are considering it at the moment. One British firm who've said no thank you, and a couple who are trembling in the brink.
Is this an Imperial first, or is this sort of device being developed elsewhere in the world?
No, I think as far as the solid-state device goes, this is an Imperial College first. People have talked about inserting atoms into tungsten trioxide using a liquid electrolyte. They're no good.
You're convinced that we're ahead of the Americans in this field?
Oh yes, and the Japanese, even more important in this day.
Well, Dr. Green, thank you very much for coming along, and wish you success with your device.
Thank you very much.